Okay, so now let's look at another two practice problem here. So let ABC be three events in the sample space S, and assume we know that A union B union C equals S. Okay, and PA is 1 over 2, PB is 3 over 4, P A union B is equal to 2 over 3. Okay. So there's some hints. Let's do it one by one. So first one, P A intersect B equals to P A plus PB minus P A union B. This is based on the inclusion-exclusion principle. So we know that PA is 1 over 2, PB is 3 over 4, PA union B is 2 over 3. So we can let them to have same denominator, so it's 6 over 12 plus 9 over 12 minus 8 over 12, right? So we're going to have the 7 over 12 as the first one. Okay. Okay, so that's the first problem. Do ABC form a partition of S? Talking about the partition of a set, you have to satisfy two conditions. First of all, the union of those sets is going to be the sample space S, or satisfy that. But meanwhile, all the sets are pairwise disjoint. Okay, so in other words, if ABC is a partition, it's going to be something like this. Okay, so in other words, ABC, A, B, C must be pairwise disjoint. If it's a pairwise disjoint, we know that the probability of the intersection must equal to 0. But our P intersect B, it's 7 over 12. It's not equal to 0. Hence, this is not a partition, right? Because it's going to be some things A, there's some things B here, something like this. Okay, so it's not just, so the answer here is no. Okay, it's no. All right, so PC minus A union B. So one thing I want you to think about is, the C minus, so A union B, which also equals to PC union A union B, and then minus A union B. Okay. And you can verify that. In other words, so you can verify that part. In other words, if you do a difference of two things, and then that can be write it as this one union the second set, and then subtract that set. There's nothing changed. It's exactly the same stuff. Okay. But here, C union A union B, so we know that this is, do you agree that this is going to be the universal set? So it's going to equal to P of S minus A union B. Okay. And then, do you realize that this equals to A union B complement, right? So it's a P A union B complement. That is, it's 1 minus P A union B, And we know that P A union B is given, right? It's just 2 over 3. So it's going to be 1 minus 2 over 3. The answer is going to be a third. Okay. Last one. So it asks us to find out what is PC. Okay. So PC, and it gives us is C intersect A union B. So for here, this is A, this is B, this is C. Okay. So as you can see that A union B is here, right? A union B is A union B is right here. And then if you do C intersect A union B, don't you agree it's this PC, right? So this part is exactly, so this is C intersect A union B. But what we're looking for here is, do you agree, we're looking for probability of C, right? So you see that the probability of C, it's the probability of this part, which is given. Do you see plus the probability of this PC, right? Now how do we represent this part? Don't you think so? It's just a C subtract A union B, which is the part C we already got. So from this Venn diagram, we derive is a PC equals P of C intersect A union B plus the P of the C minus A union B here. Hence, don't you agree this is equal to 5 over 12 plus 1 over 3, which is going to be 9 over 12, which is 3 over 4. Okay, so that's the first problem here. All right. Second part. This is talking about using the Venn diagram to verify the following identities. The ABC, assume those are not disjoint. So first one, if we draw a Venn diagram, let's only consider about A and B at this stage. So you see this is set of A, this is set of B, okay? So set of A here, do you see it's right here, right? Okay. And then set of A intersect B. It's this part, right? And then the set of A minus B. Don't you see it's this part? Right. So if you let them make a union, don't you agree it equals to A here, right? So it's equals okay, that's how do we represent this part? Alright, so A and B, so A minus B is lies here, right? So that's one thing what we can think about. Since for this A intersect B complement, okay. So this is A, this is B. First of all, you see that a B complement is everything here, right? And then our A intersect B complement Don't you see that? It's just this species, right? So this is A intersect B complement. And the other stands for exactly the same thing. And also easy to notice that we have A here or B here. A intersect B is this part. Subtract of this A. Okay. And then A union B it's this, right? That's A union B. And then subtract B, A union B, and then subtract B. Don't you agree? It's just a, if you subtract B, just this part. So the same thing, okay? And then last one, C equals C intersect A union B union this one. I believe I already go through this one from the previous example, right? So A, B, C. This is our C here, right? C intersect A union B. So A union B is here, intersect is going to be this species, right? So this is C intersect A union B. And then A, B, C here. C minus A C minus A I think there should be something wrong here, right? So apologize. I think there's an error here. So this part should be A. Let me see. A intersect B. Yeah, I think this part should be union. So A union B is right here. If you do a C difference, it's going to be this part. So it should be C minus A union B. And then, so the union of those two, 126, so it gives us the completely C here. So yeah, so that should solve the problem. Okay, so thank you for the watching.